All right, and the day is here. All right, our final lesson on rational functions. And we're going to circle back to a topic we've done with lots of our functions so far, and that is finding inverses of a given function. All right, so to get us started on that, we're going to do a little bit of a review and then make some connections here. So here's what I would like you to do. All right, you're given two functions here. You're given f of x and g of x. I would like you to graph both of those rational functions. And then as you graph them, all right, label your vertical asymptote, your horizontal asymptote for each. State your domain and your range in interval notation, all right? And then looking at those two graphs, see if you make some connections. So, all right, so pause the video, take care of the opener, then turn it back on, and we'll see how you did. All right, so I'm going to throw, all right, my graph up here. All right, so I'm going to throw my graph here, like I said, had to dig it out. I had it misplaced there. All right, so let's look at both graphs here. So you can see both graphs. All right, so hopefully those match what you did. All right, if we look at the first one, we have a vertical asymptote at x equals -3. And notice our k value is 0, so our horizontal asymptote would be y equals 0. And so then our domain would be negative infinity to 3, or excuse me, -3, and then -3 to infinity. And then our range would be negative infinity to 0, and then 0 to infinity. All right, now when we look at g of x, all right, our vertical asymptote would be at x equals 0, and then we can see our k value is -3, so both of these functions are in our standard form, or excuse me, our HK form, so we should be able to recognize those very quickly now, hopefully. All right, and then our domain would be negative infinity to 0, and 0 to infinity, and then negative infinity to -3, and -3 to infinity, all right, for our range. All right, so now hopefully you made some observations here that everything is reversed, right? So the vertical asymptote, all right, and the horizontal asymptote here, right? Horizontal and vertical here. The domain and the range here. The range and the domain here, right? So everything seems to be flip-flopped. And why is that? And you may have guessed that, all right? And if you read ahead, yeah, they are inverses, all right? So I kind of had a spoiler down there, so maybe I should have had a spoiler alert for you not to read down. All right, so notice that everything is swapped, right? And we know that happens because we know with an inverse, the domain of the function becomes the range of the inverse, right? The range of the function becomes the domain of the inverse, right? So we know those are one of the properties, all right, or some of the properties we know of when we talk about inverses with all the work we've done so far this year. So that was just a refresher to kind of help you remember some of those properties, right, of our inverses. Now, what we want to do now, all right, so let's flip the page, is that we want to be able to solve for the inverse of a function. All right, in this case, we're going to specifically be solving for the inverse of our rational functions. Okay, so the first thing we want to do is make sure that it's 1-to-1. All right, and so the ones that we are going to give you will be 1-to-1, so that won't be too bad for you right now. All right. Then what we said is that we want to then, since we're inverses, we're going to swap the x and the y's, right? We're going to switch the domain and the range, and we're going to solve for that new y, and then we're going to make sure we use our inverse notation, right? F inverse of x, right? So we want to make sure we use our inverse notation to note that we have now finished and we have an inverse function. Now, the other thing that we're going to do, even though it's not listed up here, if you kind of look down at number 1, all right, is that we're going to look at the domain and range, all right, of our functions, because we should know what those are going to be, all right, before we do all the solving, and that will help us verify our work at the end. So, for example, when I look at f of x right now, all right, this is in HK form. I can see that my vertical asymptote would be at x equals 6, so then I know the only value, right, I can't use is 6. So I know my domain would be negative infinity to 6 and then 6 to infinity, right? And then I know my k value is 0 out here, right? So that's my horizontal asymptote. So then I know my range, all right, will be negative infinity to 0, union 0 to infinity. Now, here's why we're doing this, because here's what we know. We know the domain and the range switch when we take and solve for our inverses. So the domain, all right, of my f inverse here, of my inverse function, should be the range of my original function. So it should be, all right, negative infinity to 0 and then 0 to infinity. And then the range should be the domain here. So I want to have negative infinity to 6 union 6 to infinity. So if we do everything correctly, all right, that should work out. So this we know should be true. So the function we solve for should give us a domain of this and a range of this. All right, so now let's get into the solving of our function. So f of x really just means y. So we're going to say y equals negative 4 over x minus 6. All right, and then now I'm going to swap my x and my y variables. So I'm going to have x here equals negative 4 over y minus 6. Now, in this particular case, I'm going to show you a property of proportions if you're unfamiliar with. It really makes the solving much easier. All right, and so when we have a proportion, and remember I can put that left side over 1, one of our properties of proportion says that I can switch these two values, and it would be equivalent. So what I can do is take the y minus 6 and move it to this numerator, and I can move the x to that denominator. So this would become negative 4 over x like that. And notice that speeds up our solving process by using one of those properties. All right, so I can just take that whole quantity, all right, and switch it. And so now, to solve for this y, all I have to do is add 6 to both sides. So I get y equals negative 4 over x plus 6. And notice now this is my inverse function, negative 4 over x plus 6. Now let's take this function and look right at its domain and range and see if it matches what we have here. So notice, I would have a vertical asymptote at 0. So that means my domain would be everything but 0, which is what we wrote right here. I can see that my k value is 6. So that means my horizontal asymptote is at 6. That means I would have all the y values in my range except for 6, which is what we wrote right here. All right, so we're kind of using some initial things that we know about inverse functions, right? And then we can have that information on hand once we finish solving. And if they don't match, something went wrong. All right, so that helps us kind of verify our work. All right, so let's take a look at number 2 here. All right, so once again, let's start with our domain and range of our original function. Once again, we're in HK form here. So I can see that my vertical asymptote would be at negative 7. So I know my domain would be everything but negative 7. So in interval notation, it would look like that. I can see that my k value is negative 8. So I would get everything in my range but negative 8. So I'm going to get this guy right here, like so. Now, once again, if we swap those, knowing what's going to happen with our inverses, in my domain of my inverse should be negative infinity to negative 8, and then negative 8 to infinity. My 8 almost tried to turn into infinity symbol there. All right, and then my range is now going to be, all right, negative infinity to negative 7, union negative 7 to infinity. And so once again, we should be able to see this once we finish solving. All right, so once again, let's go ahead and just put a y in here. So y equals 5 over x plus 7 minus 8. All right, and now let's swap those variables. So this is going to become an x, and then this is 5 over y plus 7, and then I still have the minus 8 up here. So now, once again, before, notice we have an extra step here, because in our previous problem, we didn't have a k value out here. So now I have this minus 8. So the first thing I want to do, all right, is I want to add that 8 to both sides. And so I get x plus 8 equals 5 over y plus 7. Because once I do that, once again, I get back to this step right here to where I create a proportion. And so notice now this is really over 1. And so once again, now I get to use that property of proportions where I can switch that numerator and that denominator. So notice this becomes y plus 7 in the numerator here over 5 over x plus 8 here. And so that really speeds up our solving process, all right, knowing that property of proportions. And so notice in my final step here to solve for y is I just have to subtract 7 from both sides, and I would get y equals 5 over x plus 8 minus 7. All right, and then that would be our inversion. Notice it's a g of x this time, so I'm just going to write g inverse of x equals 5 over x plus 8, and then minus 7. Now, once again, hopefully what we've already written for our domain and range holds true for what we have right here. All right, so notice, all right, my vertical asymptote would be at negative 8. So my domain would be everything but negative 8. And I can see that in the domain I wrote right here. My k value is negative 7. So that would be the equation of my horizontal asymptote. So I know I'd get everything but negative 7, which is this guy right here. So it matches. So once again, this kind of pre-work just gives us a way of verifying everything at the end. All right, so let's do one more of these together. All right, so let's look at number 3. All right, so notice sometimes we get a little bit fancy here. All right, and we may have to do a little bit of working here. So what I know is that 3x minus 7 can't be equal to 0. So 3x can't be equal to 7, which means x can't be equal to 7/3. So my vertical asymptote, all right, is going to be at 7/3. So remember, if it's not as obvious when you have these simpler linear factors, right, you can tell it's 6, you can tell it's -7, remember, you can just set it equal to 0 and solve, all right? So then what we know is that our domain would be from -infinity to 7/3 union 7/3 to infinity, all right? And now, all right, I can see that my k value is 2, so that's where my horizontal asymptote would be, so then my range would be -infinity to 2 union 2 to infinity, all right? So now, once again, let's just go ahead and swap my domain and my range. So now the inverse should have a domain of -infinity to 2 union 2 to infinity. And then the range of my inverse should have a -infinity to 7/3 union 7/3 to infinity. All right, so let's go ahead and solve and see if we can get an equation, all right, a function that matches that. So once again, I'm just going to throw our y variable in here, like so. I'm going to swap our x and our y, like we did just a second ago. All right, and then bring down that +2. Now, once again, we want to subtract that 2 first. So I'm going to do that. And notice that gives us x minus 2 equals -2 over 3y minus 7. And once again, we get into this idea now of that proportion. So we can use that property of proportions. We can switch these two guys. So I get 3y minus 7 equals -2 over x minus 2. All right, so now, all right, notice we get into a little bit more solving. So we have a little bit more complexity here. All right, and so we still need to add 7 first, much like we did in the last one. So I get 3y equals -2 over x minus 2 plus 7. All right, so now, all right, I need to divide. All right, I need to divide everything by 3. So I need to divide this by 3, I need to divide this by 3, and I need to divide that by 3. All right, so now when I do that, that leaves me the y. Now this is pretty obvious because I can see that that's going to be plus 7/3. Now when I divide everything here, this 3, all right, so we already have a fraction here. This 3 just ends up in the denominator. So this would be -2 and then 3 times x minus 2, like that, all right, because I'm already dividing, right, okay, and that would be the same thing as dividing by 3 is the same thing as multiplying by 1/3, which is why it simplifies to this. Now, once again, look at what we are left with, right? My vertical asymptote would be at 2 here, which is matching with what we wrote here. My horizontal asymptote would be at 7/3, which once again matches what we wrote right there. All right, so now let's do one more problem together. All right, so problem 4 here, and this is the most complex that we will see. All right, and so let's go through this one. Now, once again, our vertical asymptote would be at 3 here. We can see that very clearly. So we have -infinity to 3, union 3 to infinity. Now notice, this is now in a different form. So we have to find our horizontal asymptote using that ratio, all right, using those 3 situations we talked about when it's not in HK form. So we have the same degree in the numerator, same degree in the denominator, so we know the horizontal asymptote is going to be the ratio of those leading coefficients, which in this case would be 2 to 1. So then our range, all right, would be -infinity to 2, union 2 to infinity. Now, this is just a little bit more complex because it requires a little bit more solving as we go through the process. All right, so let's look at that. So I'm going to put my y in here, like that. All right, now I'm going to swap my variables. Now, here's why it's more complex, because this y becomes an x. But notice now I have 2 x's, so both of those x's become a y. So I get 2y plus 5 over y minus 3. All right, so now here's what we want to do. Now we want to cross multiply, and all right, and we're not going to swap, and you'll see why in just a moment. All right, so now I'm going to multiply here. So I'm going to get x times y minus 3 equals 2y plus 5, like that. And I'm going to do x times y, and I'm going to do x times -3 on the left side, like that. Now, here's why I wanted to cross multiply, because I have more than one y. All right, versus in this problem, I could just swap these because that allowed me to get the y by itself because I only had one y. When I have more than one y, I need to multiply, all right, distribute everything out, and then I need to gather everything that has a y in it to one side. So what I need to do is move this y over. So I'm going to subtract 2y from both sides. And then I want to move everything without a y to the other side. So I'm going to add this 3x, and I'm going to add 3x here. So that's 0, that's 0. So notice what I'm left with here. I get negative 2y plus xy equals 5 plus 3x. That's an x there. All right. Now here's why we do that. Because I now need to factor the y out of my terms on the left. So notice I can factor that y out, and that would leave me negative 2 plus x equals 5 plus 3x. And now I can divide by that entire quantity right there. All right. Oop, I put a 5. That should be an x. Let me change that to an x. All right. And so that is 1. Now, if I bring this up here, notice I get y equals. Now I'm going to write this in different order. Put the x term first. Same thing here. I'm going to just rewrite that. That's going to be x minus 2. All right, like so. All right, and there's our inverse. All right, so there's p prime of x equals 3x plus 5 over x minus 2. All right, so now let's look at our vertical asymptote. It would be at 2. And notice I forgot to flip our domain and arrange here, but you can see that that does match what we had earlier, just like that. Now, once again, now we're in that same form that we started with, right? The degree of the numerator is equal to the degree of the denominator. So my horizontal asymptote would be the ratio of those leading coefficients. So that would be 3 to 1. And now notice if I had flipped this at the beginning like I should have, that confirms what we have. All right, so there it is, my friends. So that is how we solve for the inverse of rational functions. So I've enjoyed working with you. All right, be sure to do your video check-in, and I will see you with our next unit.